Bangladesh, to everyone present here today. It's an honor to be part of 10th International Conference on NLP 2021. So this is Afia Fairoose and I'll be presenting our research work, which is on a deep learning approach to integrate human level understanding in a chatbot. So before I move on to how we did our work, firstly, I would like to talk about our main purpose for working in this research. We know that chatbots are one of the most advanced features incorporated in most organizations and online platforms today. And of course, virtual assistant helps to provide faster and efficient response in client service sector. But if you see most of the bots in the market, which are connected to different applications, they cannot actually help the customers efficiently. Why? Because most of the time, the replies are very redundant, or the main problem is they don't understand what the customer exactly wants. Of course, they're machines, right? So how they're trained, in most cases, they're trained by a fixed data set of question answers where when an input sentence is given, the machine tries to find something closely related from its database and replies with it. So this creates a lot of problem, and that's why customers does not find it handy to use chatbots till now. So due to this, we decided why not we work on it, and when we analyzed it, we actually found out that for a chatbot to generate a proper, accurate dialogue, it's more necessary for a machine to understand the text. So just like how we humans do it, we try to understand the context, understand what kind of mood the person is going through, whatever the person is trying to say and what he or she is referring to. Similarly, we try to do it in a machine. And in our research, we studied that there are a lot of key elements that are necessary for a chatbot to analyze before it can actually interpret a dialogue. And what are they? The first thing is the sentiment. So our bot, we trained our bot with sentiment analysis, emotion detection, intent classification, and finally name entity recognition. We incorporated all of them so that the bot is able to understand a text, an input text properly. In short, we can say that we are trying to train a machine that can mimic human understanding level. All right. So before we went to our work, we did some research in the same topic we have worked, and we have seen that most of the paper actually worked with single features. That is either a paper that wants to work with bots, they have done sentiment analysis, or they have done emotion detection, or maybe intent classification. But through our research, we haven't found much paper that actually incorporate all of them, where we understand that every single element is necessary to understand a text. And again, what I said previously, that most of the bots are trained with fixed question answer responses. So that's why the conversation with the bot actually does not give a human vibe. It's more machine, because the machine actually doesn't understand anything. And we have also seen that when bots are trained with machine learning algorithms, which had not much good accuracy. And we also read a survey paper where we have seen that deep learning models outweigh other learning models, and that's why we have chose deep learning for our research. So yeah, this is our research methodology. So what we did is, if a user gives a text, the text will go under sentiment analysis, emotion detection, intent classification, name entity recognition, and after all this, through a single parameter, from the dialogue, the machine will interpret each of them, the sentiment of the dialogue, the emotion, the intent, and the name entity. So yeah, so through our research methodology, we have firstly started with sentiment analysis. Now, in sentiment analysis, in a given text, the person can actually the machine can interpret the polarity of the text, that is, whether the sentence is a negative sentence or it is a positive sentence. So this is our work plan for sentiment analysis. Here, firstly, we took two datasets. One is from IMDb dataset. Another is Twitter dataset. From these two datasets, we trained our model. We have used a number of models. One is simple neural network, one is LSTM, and another is GRU. So firstly, we cleaned the dataset, and yes, how we did it, we removed HTML tags, converted the apostrophe words to a proper word so that it's easier for the machine to understand. Then we have removed single letters, spaces, dots, backslash, removed unnecessary URLs, words, and then we tokenized it. We have converted from text to sequence. We have also done padding so that all the sentences are of same length. And of course, here we can see that we have labeled our sentiment in positive to 1 and negative to 0. And our train and test split was in the ratio 1:3. And after that, we have actually fed it to our neural network models to train. And as our data is textual, we of course needed to convert it into numerical form. So to capture the context of the word, we use Stanford Glove dataset. And we used Adam Optimizer and binary cross entropy for our loss function. So then after all this, our actually training was performed, and after this training, the model was saved so that we can use it with real data for testing. And also we know one thing that for deep learning models, it is actually important to keep the batch size moderate for training. Why? Because to get rid of some common problems that we face, one is overfitting, another is underfitting. So for this, we have used batch size of 128, epoch 20, and validation split of 0.2 for all the models. Also, we have used some other approaches to get rid of overfitting problems, such as regularization technique, adding dropout to 0.5, and adding moderate dense layers, etc. So here's our experimental results. We have experimental results from individual models, and the training and tests were done on 2 different data sets. Here we can see the accuracies, and from here we can actually say that GRU has given us the highest accuracy for training and validation for both the data set. So so from here we have found that GRU is optimum for sentiment analysis in this part. All right. Okay, I just made a mistake. Sorry, it's LSTM. Absolutely sorry for that. It's LSTM, which we found out the accuracy is greater in training and validation compared to the other models. The training for IMDb was 0.989 and validation is 0.80, whereas for tutor dataset, it's 0.86, and for validation, it's 0.71. So LSTM is convenient for, LSTM has outperformed all other models in sentiment analysis. And then we have applied it in our bot, which is BandhuBot. Here we have tried a number of sentences. For example, hey, you're a good bot. So of course, this is a positive sentence. Again, there is no, actually, you're a bad bot. This is a negative sentence. Now, these are very simple sentences, and it's easier to detect the sentiment. So we have also given a complex sentence here. For example, you are a good bot, but the behavior that you did yesterday was not fair. Now, if we see this line, it's easier for a human to detect this because we understand that it's actually not a positive sentiment, though the first part of the sentence says something good. So, but we have seen that our machine was able to identify the more emphasis that the sentence had on negative part, and so our predicted sentiment was accurate. this was a great achievement for us. And this was one more reason why we used deep learning models, because they work better on complex sentences. All right, next is our emotion detection. Okay, before I move to emotion data, one more thing I would like to speak about sentiment. That is how our bot predicted. We set the confidence levels from 0 to 1. So if the value was greater than 0.5, our bot predicted a positive sentiment. Again, if the value was less than 0.5, the bot predicted a negative sentiment. All right. So emotion detection. Through sentiment analysis, we know a person can just get the polarity of the user, or if we talk about machine just understands the polarity, whether it's a positive sentence or a negative sentence. For example, I couldn't sleep because I had a bad dream. Now, the sentiment is negative. However, we don't know what specific emotion he was going through, whether the person was sad or uttered the sentence in fear. We don't know what the person actually expressed. So for this reason, we have also done emotion detection. So emotions, we know that emotions are very subtle and ambiguous in a text, which makes it really difficult to detect. And that's why also we have used neural network models to train it. We have used bidirectional LSTM and GRU to train our ISEAR dataset, which is International Survey of Emotion Antecedent and Reaction dataset. So here we have used, in our dataset, we have 7 categories of emotion, which is sad, joy, disgust, guilt, anger, and shame. Yes, there are 7 categories, and similar to the previous one, we have cleaned the dataset and then we have tokenized it. We have converted the categories, the textual categories, into numerical form using one-hot encoder. And then we have also trained our model using dropout to 0.5, batch 232, and epoch 100. And then we have fed to the neural network model and set it for testing. Here, from our experimental results, we can see that LSTM gives 0.9 in training, and almost similar is bidirectional GRU, but in validation, bidirectional GRU outperforms bidirectional LSTM. So we have chosen bidirectional GRU model for our emotion detection. Here we have tested our emotion as well, and we can see different kinds of emotions are predicted. Let's say I did not help out enough at my thesis team. The predicted emotion was guilt first. Someone stole my pen. Predicted emotion was anger. My boyfriend left me. So predicted emotion was sadness. And again, there is a complex sentence here. Some people are unfairly treated because of their nationality and color. So the predicted emotion is disgust. So this was our testing, and we successfully, our machine was able to predict all the emotions. Then is intent classification. So now we know the sentiment, also the emotion, the person, what emotional state the person is going through. Now, what we need to figure out is that why the person is in this particular situation. So for this why reason, we need to actually find the intent of the text. So we had to do intent classification. So intent classification, what it does, it actually finds the intention behind the text or a speech. Here we have used a banking data set which had different categories, banking related problems, and there were different categories of banking problems. So here also we have followed the same method, cleaning the data set, tokenizing it, going through one hot encoder, training and testing, and then finally feeding into neural network model. We have also used here bidirectional LSTM and GRU. So if we go to our experimental results, we will see that, bidirectional LSTM outperforms, then a bidirectional GRU, it's 0.774 in training and 0.71 in validation. And we have also tested the intent. And here, if we see, since it was a banking data set, we tried to use some banking related text. For example, if I see the second text, it's I'm still waiting on my card. The predicted intent is card arrival. Then which countries are linked with your bank? This says country support. And again, can I get a new card? This predicts an intent order physical card. So yeah, our intents were actually predicted accurately. Now, finally comes our name entity recognition. So we have also now known that the intent or the intention behind the text. Now we need to know where is this intent referring to. It could be a location, it could be a specific date or time, it could be a place, it could be a known person. So if we know the intent, it's more easier to be more specific about the cause. So by extracting the entities, machine can know about whom, where, and which date or time the context of the sentence is referring. And here also we have used by LSTM and GRU. And here we have used a GMB corpus for predicting the time, location, organization, etc. The workflow is absolutely similar to our previous work. And then we have the experimental results. So we can see here that the accuracies of by LSTM and by GRU is almost similar. So we can keep either one as a preferable model for our name entity recognition. So long we have done sentiment analysis, emotion detection, intent classification, and name entity recognition. And here, if we see our test on name entity recognition, we can see that I will travel from London to Wales next Monday. So this is a sentence I'm texting, and here our machine were able to identify the correct entities. For example, London is a it's a place. So US is a place, and Monday is time. If you see this, this will be a good application for the travel agencies if we want to book tickets with a virtual assistant rather than a physical person. So this can be a good application for that, if the name entities can be correctly recognized. If you see the last example here, it's, can I work in Google India office? So here, Google is an organization, and then India is a geolocation. All right. Finally, we have integrated all the components today. As I have said in our research work, when we give it input text, all our the sentence will go through all the individual analysis, and we will get the predicted elements from our text. So here, if we see, let's see the second sentence. For example, I lost my phone yesterday, so I could not help out enough to my thesis team. So if we see, if this is a text that is given to a virtual assistant, how it understands the sentence. So the predicted sentiment is negative, of course, because that person lost his phone. Also, he couldn't help the person in thesis. And the emotion is guilt. Of course, he couldn't help the thesis team, so he's supposed to be in guilt. And the predicted intent is lost or stolen phone. Yes, his phone was stolen. The purpose of this conversation was this, and predicted entity was yesterday. So this actually broke down the entire sentence into whatever we need, just like how as a human we do. If we see the last one, I need a new card before 9th April as I'm going to United States from Indonesia to meet with the US president. So here it's a positive, of course, he's meeting a president, and the emotion is joy. The predicted intent is country support. Predicted intent is 9th April, United. So if you see this, there's a lot of entities, and our machine was able to identify all the entities present here. All right, what were the benefits of our research? Now, as I have previously said, the issues with e-commerce business, and in pandemic, we know that everything is transformed online, transferred online, everything's working online. It's very difficult for a human to monitor everything, so why not virtual assistants? And if we have a better virtual assistant that can communicate well, that can understand or analyze a sentence well, that can be very helpful for e-commerce businesses. Also, it can be very helpful in medical field. How a virtual assistant can work as a psychiatrist if it's trained properly, if it can understand or find out the right context of the person, it can give feedback just like a psychiatrist. Though, yeah, it needs a lot of training for that. And then data of interpretation can be used for specific finding. This means that, let's say in a university, the students, the university wants to know whether the students are, what kind of problems the students are facing. What exactly, let's say there's a course X, and the teacher wants to know what kind of exact problems the students are facing. So if our bot is able to break down the individual elements of the text that a student gives, we can use this data as a resource. The teacher can use this data to actually know what are the problems the students are facing. Are they actually happy with the course or not happy? And what are the problems? What is the intent? And what kind of specific problems they have? And again, if this understanding is used for dialogue generation, then definitely it will be more accurate and interactive. So conclusion here, it's that we have actually done analysis of all components using deep learning, because deep learning is much better than other or machine learning, at least now. And then we have our machine was able to predict accurately sentiment, emotion, and intent and entities. And application of different personalized chatbots can be envisioned. So people can use this for their different applications of chatbots. And we plan to do a future work for making an interactive dialogue generation through using our the work we have done now, that implementing a human-like understanding in a chatbot. So yeah, this was all for me. Thank you.
Thank you very much. The presentation is a great one.
Thank you so much.